right, PreCalculus, we're back. This is part 2 of section 1.4.1. We're going to talk about critical points in Extrema, which are like maximum and minimum values. We talked about these in Algebra 2, so this shouldn't be new for you. Remember, a maximum point would be like the highest, the largest f of x value. The point, how about the point where the largest f of x value occurs on the graph of a function. You'll catch up eventually, there we go. On the graph of a function. All right. Whereas a minimum is the point, or I could say a point, where the smallest f of x value occurs on the graph of a function. All right, so if we look at this graph here to the left, it looks better in your textbook, so by all means, if you want to see a non-pixelated version of this graph, it looks bad on my computer, but you should be able to get a nice clear picture in your textbook, section 1.4.1. So a maximum is going to be where we have a point that is like the highest point for some interval of the function. So say between here and here, this would be my what's called a relative maximum, and we'll talk about that in a second. So over that smaller interval, that's my relative maximum, whereas the lowest point down here would be my relative minimum, because it's the lowest point in the graph for a certain area. So relative just means over a small interval, or even over a big interval, but not over the entire function. So absolute or global max or minimum is over the entire domain. So looking back up at this example that we have, do we have an absolute maximum? Is there a point on this graph that you can say for the entire graph, this is the highest point? No. This is the highest point for part of the graph, but it goes higher here. So as we go, it's going to go on and on to where? Infinity. So it's going to keep getting higher and higher and higher. So I can't say I have an absolute maximum for this graph, just like I can't say I have an absolute minimum for this graph, because it'll go on and on forever in the opposite direction. So these are relative maximum and minimums, but there's not an these are relative maximums or relative minimum, but we do not have an absolute maximum or an absolute minimum. We'll see some graphs where we do. And the other thing that could be a critical value, and these critical points are really important in calculus, so that's why we start talking about them in PreCalculus, is what's called a point of inflection. And so this is a point on the graph of a function. Graph of a function where concavity changes. All right, so what do we mean by concavity? I think we talked about it last year, but we've got concave up and concave down. So these are the shapes of the curves that make up our graph. If it's concave up, it looks like this. If it's concave down, it's a curve that looks like this. And the way I was taught to remember it is if you were to pour water on your concave up piece, it would hold the water like it was in a cup. So concave up holds water like a cup. Whereas concave down, if you pour water on that portion of the graph, it's going to fall off either side of the hill, but it's not going to collect water. The water is going to run off. So this piece here would be concave up, because if I poured water, it would kind of hold on to it, right? Now, it turns into a concave down, so if it was right here, it would end up falling down. But suppose for this part of my graph, if I had a wall here and a wall here, and I poured some rain in, it would collect, right? So that portion is concave up. This portion over here, it would run off, so that's concave down. And this point in between, cannot erase, this point in between where we went from concave up to concave down is called a point of inflection. And like I said, that can also be a critical value of our graph. So looking at an example here, where do you see a relative, well, first of all, an absolute maximum or absolute minimum? No, right? The graph keeps going down forever. Down here, keeps going up forever. So we don't have an absolute max or an absolute min. But here, I've got a relative maximum. And here, I would have a relative minimum. So our relative maximum, where does that look like it occurs at? And again, we typically write at x equals. Looks like it's like, I don't know, negative a half or so, negative 0.5. So at negative 0.5, I have a relative maximum. If I were to ask you, what is your relative maximum value? So with a value of, well, that looks like maybe a tenth to me. I don't know, 1/10. So the value is your y, right? But if I say where's the relative maximum at, it's at x equals negative 0.5. Where is my relative minimum at? Well, that's at approximately x equals 1. So that looks pretty dead on. What's my relative min value? That would be negative 1. And then if I just ask you at what point, you're just giving a point. Negative 0.5, 1/10. This point would be 1, 1. Now, why do I go through the trouble of saying all these different things? Because they're awfully confusing. The reason is because mathematicians will say different things. Some of them will say, well, it's got a relative maximum at x equals negative 0.5. Whereas another mathematician will say, oh no, you've got to write it as the relative maximum is at this point. When you take a PSAT, they could ask you anything. They could say, well, what's the relative maximum value of this graph? Well, the relative max value would be 1/10. Does that make sense? So it can get real confusing if you've never heard of these things before. So I'm going to try to throw all those different terms at you so that you know the relative maximum occurs at x equals negative 0.5. The relative maximum value is 1/10, and then if I asked you at what point, or you saw a point listed there, you would know how to find that one. All right. Let's do one more together, and then I'll let you try the last one. Look at this one here. Do we have an absolute maximum? Yes, this one we do, right? This is the absolute top of this graph. Good. And what is that point? I'm just going to do the whole point. Absolute maximum at, let's see, that looks like x is 1, y is 1, 2, 3. All right. Well, if this is an absolute maximum, this one's still kind of high for the area around it. So what do we call that one? That one is a relative maximum, right? It's high. It's not the highest, but it's high for, say from here to here. It's the highest value. And where does that one occur? Well, that's like negative 1.5, 2. Do we have any other extrema on this graph? You betcha. We've got this guy here. Is that a absolute minimum? No, right? Because it keeps going down and down. So I don't have an absolute minimum, but this is a relative minimum. And we would say that occurs at, what is that, negative 0.25, 1/4, and then negative 1/4. You might call it negative half, I'd accept that. Can't get too particular with a graph, right? Unless we're a graphing calculator. All right, you try B. I saved a juicy one for you because I see lots going on in this one. Go ahead and pause your video. All right, if you're back, that means you have figured out. First of all, do we have an absolute maximum? No, it keeps going on and on forever here. No absolute maximum. Absolute minimum? No, it keeps on going down and down forever, so no absolute minimum. We do have, it looks like 1, 2 relative maximums and 1, 2 relative minimums. So relative max at, let's call this first one. What is that? That looks really close to -1, 2. We also have one at, that one's harder to call. I'll call it a half. And then our relative mins, one of them's right there at 0, 0. And the other one's down here, kind of close to 2, 1, 2, 3, 4, 2, -4, but just less than that. So 1.9, -3.9. How fancy is that, right? All right, so that's our critical values, maximum, minimum, point of inflection. I didn't see a lot of point of inflections, unfortunately. We will hopefully find some graphs that are more obvious in their point of inflections. You guys have a good night. We'll talk about this on Friday, and that long weekend is coming. I'm off to grade your tests.